Imagine a clear night sky, countless stars scattered across the darkness, twinkling softly like diamonds. They seem calm, still, and eternal. The constellations Orion, Ursa Major, the Southern Cross, hold their familiar shapes year after year. Yet, if we look closer, the truth is far more fascinating. The stars are never truly still. They're all moving, every single one of them, but we don't notice it. Why do some stars appear to move across the sky while others seem fixed in place? The answer lies in the motion of our planet, the immense distances of space, and the subtle dance of the cosmos that unfolds across unimaginable timescales. As Earth spins on its axis, it gives the illusion that the stars are moving. Every 24 hours, our planet completes one full rotation, and this spinning motion makes the stars appear to travel from east to west across the night sky. It's the same reason the sun rises and sets, not because it moves around us, but because we are turning. If you were standing on a merry-go-round at night, the surrounding lights would seem to move in circles, even though you're the one spinning. The same thing happens when we look at the stars from our rotating planet. Now, not every star seems to move the same way. Some appear almost completely still, like Polaris, the North Star. Polaris sits almost exactly above Earth's North Pole, directly in line with our planet's axis of rotation. As the Earth turns, every star in the sky seems to move in an arc around this point, except Polaris. It holds its place, a bright and steady anchor in the northern sky. For thousands of years, travelers have used this star as a celestial compass, always pointing north. If you could watch the stars all night, you'd notice something mesmerizing. The stars near Polaris make small, tight circles. Those farther away trace wide arcs across the sky. In the southern hemisphere, where Polaris is invisible, stars seem to rotate around a different, invisible point, the south celestial pole. This slow, graceful rotation of the heavens is one of the most beautiful illusions created by Earth's motion. But why do stars like Polaris appear so steady while others seem to wander across the sky? The answer also lies in distance. Stars are unimaginably far away. Take Proxima Centauri, the closest star beyond our Sun. It's over 4 light-years away. That means the light you see from it tonight actually began its journey over 4 years ago. Because these stars are so distant, even though they're moving at incredible speeds, thousands of kilometers per second, their motion is too small for our eyes to detect. To us, they appear frozen in place, painting a seemingly unchanging canvas across the night. This immense distance creates what astronomers call the fixed stars. The ancient Greeks noticed that while the planets, which they called wanderers, shifted positions against the starry background, most stars remained fixed in place, forming patterns we now know as constellations. These constellations are human creations, mental connections between far-flung points of light. And because those stars are so far apart, the patterns appear constant for thousands of years, even though, in reality, the stars themselves are all moving. Earth's yearly journey around the Sun adds another layer to this cosmic illusion. As we orbit, our perspective changes slightly, and nearby stars seem to shift against the background of distant ones. This effect is called stellar parallax, and it's one of the most important tools astronomers use to measure distances in space. But for the vast majority of stars, this shift is so tiny that it's invisible without powerful telescopes and sensitive instruments. The nearest stars may show a tiny wobble over the course of a year, but to our naked eyes, the heavens appear still. Even though stars seem fixed, each one is actually racing through the galaxy. Our Sun, for example, is hurtling around the center of the Milky Way at over 220 kilometers per second. Every other star in our galaxy is doing the same, orbiting the galactic core under the pull of gravity. Some stars move in nearly perfect circles. Others take long, looping paths. And just like planets around the Sun, stars can influence one another through gravity, nudging and shifting their paths ever so slightly. These movements are real, but they happen over millions or even billions of years, so from our short human perspective, the stars appear motionless. If we could fast forward time, say, over millions of years, the constellations we know today would begin to distort. Orion's belt might bend, the Big Dipper would stretch, and familiar patterns would vanish. The sky would look entirely different. But for us, living in just a blink of cosmic time, it feels eternal and unchanging. There's another subtle effect at play, something called proper motion, which is the actual motion of stars through space. Some stars, especially the ones closer to Earth, have noticeable proper motion when measured precisely. For instance, Barnard's star, one of our nearest neighbors, moves faster across our sky than any other known star, though even it would take centuries for us to see a noticeable change without instruments. When we put all of this together, Earth's rotation, its orbit, the vast distances to the stars, and their own slow journeys through space, we begin to understand the magic of why the night sky looks the way it does. The stars that appear to move are simply part of the illusion created by our spinning and orbiting world. The ones that seem fixed, like Polaris, owe their stability to their position and alignment with our planet's axis. And yet, beyond the illusion, there's a living universe. Every star is part of a massive swirling galaxy filled with motion and energy. Stars are born inside enormous clouds of gas and dust, shine for billions of years, and eventually die in spectacular explosions called supernova or fade away into white dwarfs. Some massive stars even disappear entirely, collapsing into black holes, leaving patches of darkness where light once was. Even as they live out their life cycles, the stars continue to drift, reshaping the structure of our galaxy. Across the universe, in billions of other galaxies, the same dance plays out, stars orbiting, colliding, and moving in graceful, invisible motion. And yet, from our tiny blue planet, all we see is a calm, glittering dome of lights. So the reason some stars appear to move while others seem fixed is not because some are alive and others still, it's because of perspective. We're on a moving planet, circling a moving star, inside a galaxy that's spinning through space. The stars only appear still because their distances are vast, their motions slow, and our lifetimes brief. Every night when we look up, we're witnessing an ancient illusion, a slow cosmic ballet that unfolds so gradually we can't perceive it. The stars we see tonight aren't where they appear to be. Their light has traveled years, sometimes centuries, to reach us. They may have already moved or even ceased to exist. Yet their glow continues, connecting us to a universe in constant motion. And that's the beauty of it, the night sky isn't frozen. It's alive, dynamic, and ever-changing. Every star is a traveler, every constellation a fleeting pattern in time. From Earth, we see a still picture, but beyond that stillness lies the heartbeat of the cosmos, silent, steady, and eternal.